Hello students, we are back with the chapter aldehyde, ketones and carboxylic acid. Now student, in this particular module, we are actually doing the continuation of the previous module. That's nucleophilic addition. Here, we are going to discuss the mechanism of nucleophilic addition of HCN on benzaldehyde student. Let's now see what is the action of HCN on benzaldehyde first. So I have got a benzaldehyde on the screen. Now it has to be treated with HCN, and we already know that your cyanide group, okay, this reaction has to be done in presence of OH minus ion. Student, do you remember that? Yes. What will happen? Your cyanide, which is a nucleophilic part, will get attached to a carbonyl carbon, and your hydrogen will get attached to a carbonyl oxygen. So I'll write the same molecule as it is if you see. And what will happen to that if you see? Your cyanide will get attached to a carbonyl carbon, and hence your hydrogen will get attached to oxygen atom. So what you are going to get over here? Your benzaldehyde having one OH group and one cyanide group. The name of this particular compound is cyanohydrin, student, remember, but it is obtained from benzaldehyde, so can I name it as benzaldehyde cyanohydrin, which is also known as mendelonitrile, student. Now student, this is something very important for a board exam. They may ask you, how will you convert your benzaldehyde into mendelonitrile? This would be the reaction for a student. Now let's go to the mechanism of this reaction, student. Here I have got several steps for it. The first step, I have got an HCN. Student, remember that HCN is a weak acid which will not get dissociate, and you will not get your nucleophile easily. So what we have done, we have added a base. Now what is the role of a base? To increase the rate of formation of a nucleophile. Let's see that. What is the base, student? Remember that base is nothing but a substance which has got a tendency to abstract hydrogen. That's nothing but, you can see over here, a base is taking that H from the HCN, and hence what will happen, due to which a water molecule is going to be formed, and your Cn minus ion would be generated, which is nothing but a nucleophile. Yes or no, student? So can we name this step as generation of a nucleophile? Now this nucleophile only will be attacking to a benzaldehyde, where the reaction will then later on proceed to a step 2. Let's see in that step 2, student. Here in the step 2 I have got a benzaldehyde. Now benzaldehyde has been treated with cyanide, and you know that the carbonyl group is nothing but a polar. So cyanide is going to attack to a carbonyl carbon, and hence you are going to get that cyanide. And what will happen to that pi bond? Pi bond will get shifted on oxygen, making that oxygen negative. Now student, remember in the reactant side, the carbon atom, what has been shown, is sp2 hybridized, and the carbon atom in the product side is nothing but sp3 hybridized. So here, student, there is one clear indication. There is a change in the hybridization from sp2 to sp3, which can be a very important point for entrance, student. Yes. Can we tell about the geometry? It will be tetrahedral in nature. Yes, in the product, if you can see, because it's sp3. Now what will be the name of the step, student? Is it nothing but nucleophile attacking to a carbonyl carbon? Yes, it's an attack of a nucleophile to a carbonyl carbon would be the name of. Let's see finally the third step what it is, where finally the formation of a product will take place. So what I'm doing is, I'm taking the product part of the step 2 only, once again that intermediate, and I'm treating that with an HCN because it is already there inside the solution. What will happen? That oxygen negative will take that H. Yes, and it will form nothing but our desired product, which is nothing but, you can see this is the product to which now H is going to come. Will it not be a benzaldehyde cyanohydrin, student? Yes, it will be a benzaldehyde cyanohydrin. Is it not? So easy mechanism, student. Yes, let's solve one question based on this particular 2 modules what we did, based on action of HCN on aldehydes or ketones. So here there is a question. When an acetaldehyde reacts with an HCN, the product obtained will show. Option A, you can see optical isomerism. B, it's nothing but chain isomerism. C, it's a functional isomerism. And D, it's a metamerism. Now solution for this is what? Yes, student, can you see acetaldehyde reacting with what? HCN. Now what is the structure of acetaldehyde, student? It's a carbonyl group, one side CH3 and one side H. Is it acetaldehyde? Yes, student. Now what? Again, it's a nucleophilic addition. Student, remember, partial charges to be put on carbonyl group. Your HCN also will have that partial charges. Your nucleophile will attack to a carbonyl carbon, if you see, and your hydrogen will attack to carbonyl oxygen. So we are not going to get cyanide and OH. The name of this compound would be acetaldehyde cyanohydrin. What is so important in this? Can you see that carbon atom? Yes, which has been located. It is attached to 4 different groups. Can I call this carbon as a chiral carbon? Yes. So any carbon which is chiral, which is present in the compound, would show optical isomerism. Hence, I think so in our 4 option, the option is very clear. The answer is A, which is optical isomerism. Student, is it not easy? Thank you very much.